Welcome back, dear dreamer. Tonight, we drift into the quiet worlds beyond our own sky, where distant exoplanets move with a calm and ancient patience. These worlds do not glow with urgency or roar with storms we can hear. They travel through deep space with slow confidence, following rhythms older than memory, as if the universe itself guides their peaceful paths. As you listen, let each breath soften, and let your thoughts settle like starlight, gently fading across a silent horizon. This is not a story of chaos or noise. It is a gentle journey through cosmic wonder, quiet science, and the soothing beauty of worlds that shine far away from our own. Settle in, get comfortable, and let the night carry you from one peaceful moment to the next. If these soft cosmic journeys bring you comfort, remember to subscribe and tap the like button. Now, let us begin. When night settles and the sky grows soft, it's calming to imagine a distant world circling a faint star far from our own. The first confirmed exoplanets were found in 1992, around a pulsar, a star spinning like a cosmic lighthouse. Astronomers didn't expect planets to survive in such an extreme place, yet there they were, orbiting quietly as if untouched by chaos. Their discovery echoes Einstein's belief that the universe follows patterns even in the most unlikely corners. These distant worlds drift through their long orbits, glowing in starlight that never reaches Earth. Their silence feels comforting, a reminder that space has peaceful regions where time flows slowly and steadily, far from noise or hurry. Every new discovery adds to the sense that the universe is full of calm, unseen places waiting patiently for us to notice them. Light behaves in graceful ways across the quiet dark of space. Einstein predicted how gravity could bend light long before it was observed, and today this idea helps astronomers find hidden exoplanets. Through gravitational microlensing, one star briefly magnifies another, revealing any planets nearby. The effect is delicate, like a short-lived cosmic shimmer. Some of the planets found this way drift alone, not orbiting any star at all. These quiet wanderers travel through interstellar space without destination, moving at a gentle pace through the cool, open dark. When astronomers detect one, it feels like hearing a soft whisper from the universe. These silent planets remind us that not everything needs warmth or sunlight to exist. Some simply continue forward, calm and unbothered, following the natural flow of gravity. Long before telescopes were powerful enough to see distant stars flicker, ancient observers believed the night sky was fixed and unchanging. Now we know that stars are suns, and many host families of planets that orbit them with slow, steady rhythms. The Kepler Space Telescope, named after Johannes Kepler, found thousands of these hidden worlds by watching for tiny repeated dimmings in starlight. It required patience, almost like listening for gentle footsteps on a quiet floor. The planets it revealed vary widely, some smaller than Earth, some larger than Jupiter, and some wrapped in eternal twilight. Each discovery feels like another page from an ancient cosmic diary. These worlds remind us that the sky is not empty at all, but filled with peaceful, unseen places, each following its own quiet pattern. Across the galaxy, many exoplanets orbit red dwarf stars, which shine with a cool, steady glow. Their light is softer and more constant than the sun's. These stars live for trillions of years, giving their planets time to evolve slowly and peacefully. Scientists often picture these worlds as places where the sky might appear purple or deep rose, tinted by the star's gentle light. Some of these planets might be tidally locked, keeping one side always facing the star while the other remains in an endless night. Even so, the border region between light and dark could be calm and mild, offering long sunsets and soft skies. Carl Sagan often spoke of cosmic time moving in vast patient cycles, and these worlds seem to embody that idea. They orbit in steady silence, untouched by rush or noise. Some of the most intriguing exoplanets are called super-Earths, worlds larger than our own, yet smaller than Neptune. They offer a middle ground that feels peaceful to imagine. Some may hold endless oceans, stretching beneath soft cloud layers that glow gently under their star's light. Others may have thick atmospheres that trap warmth and create stable, calm climates. Astronomers study these planets using faint traces of starlight that pass through their atmospheres, looking for signatures of water vapor or other hints of habitability. The process is delicate, like trying to read a message written in mist. Edwin Hubble once suggested that the universe is stranger than we can imagine. Super-Earths give life to that thought. They drift in their quiet orbits, wrapped in mystery, inviting us to consider worlds where serenity is part of the landscape. Some planets orbit their stars so closely that their year lasts only a few hours. From afar, this might seem chaotic, but their motion is smooth and predictable, like a slow and steady pulse. Astronomers discover many of these hot planets by watching for consistent dips in starlight, each one marking another orbit completed with perfect timing. Although these worlds can be extremely hot, there's something peaceful about their regularity. Their orbits repeat endlessly, following the same path without change. Einstein's understanding of time and motion helps scientists interpret these observations, revealing how gravity shapes even the most intense environments into patterns that feel calm when viewed from a distance. These planets remind us that stability can exist even in extremes, and that beauty often appears in simple repetition. Water, one of the gentlest substances in the universe, may be common on many exoplanets. Some might have global oceans, with quiet waves rolling under soft starlight. Others could hold layers of exotic ice formed under immense pressure, smooth and still like polished crystal. Some may even hide warm subsurface seas protected beneath thick shells of ice, similar to moons in our own solar system. Astronomers search for hints of water by studying how molecules absorb starlight as it passes through a planet's atmosphere. These signals are faint and soothing, like hearing a distant, calm tone. The possibility of water creates a peaceful sense of hope. It paints pictures of serene worlds where seas stretch endlessly, untouched by storms or winds, moving in slow rhythms that could remain stable for billions of years. Among the most ancient things in the universe are planets that orbit stars much older than the Sun. These worlds have existed quietly for billions of years, circling their stars with the patience of time itself. Their surfaces may hold minerals formed during eras when galaxies were young. Studying them is like holding a piece of history. Einstein once described time and space as woven together, and these planets feel like tangible examples of that idea. They move through cosmic time without hurry, following orbits older than Earth. Their existence reminds us that the universe has a long memory. These planets are witnesses to events we can only imagine, and their silence adds a sense of depth and calm to the night sky. Rogue planets drift through the galaxy without a star to call home. They move through deep darkness, guided only by gravity. Without sunlight, they remain cold and quiet, floating like travelers in an endless night. Yet there's a peaceful beauty to their journey. Some may retain warmth deep within, created during their formation. Others may carry faint glows detectable only through sensitive instruments. They are reminders that solitude can exist without sadness. These planets follow their own slow path, free from orbits, free from cycles, moving gently through space. Their presence supports Einstein's idea that gravity connects everything, even the lonely. Rogue planets wander with quiet grace, showing that the universe has room for every kind of world, even those that travel alone. Astronomers often imagine a region around each star where temperatures might allow liquid water. This area is called the habitable zone, though it promises only possibility, not certainty. Around cool stars, this zone lies close, bathed in soft, dim light. Around hotter stars, it stretches farther out, warmed by brighter rays. The idea grew over time through early astronomy and modern physics, shaped by a deeper understanding of stellar energy. Worlds in this region may not hold life, but imagining them brings a restful feeling. They might have gentle breezes, mild climates, or long, calming twilights. Thinking of these planets invites thoughts of steady days and peaceful nights. They represent hope for other quiet places in the universe. In the quiet expanse of the galaxy, some exoplanets have rings even larger and softer in appearance than those of Saturn. These immense ring systems could stretch millions of kilometers, forming delicate arcs that glow faintly in their star's light. Scientists detect them through tiny variations in starlight during transits, almost like seeing a shadow within a shadow. These rings might be made of icy dust, gentle particles drifting in slow, steady patterns. Imagining them creates a feeling of calm, as if the planet is wrapped in a soft halo. The idea echoes early theories about planetary formation, when swirling material slowly gathered into worlds. These rings are reminders of that ancient process, still circling in quiet harmony. They move with such stability that they can last for millions of years, unbroken and serene. When astronomers model them, the gentle curves reveal a universe shaped by patience rather than force. Some distant planets are so reflective that they shine like cosmic mirrors. Their surfaces or cloud layers bounce most of their star's light back into space, making them appear brighter than Venus. This reflectivity, called albedo, helps astronomers study their atmospheres. It was a concept explored in early physics and refined with modern tools inspired by Einstein's insights into light. These worlds may be covered in clouds of fine crystals or metallic droplets that shimmer softly in the faint starlight. From afar, they would look like pale lanterns drifting through space. Their brightness feels gentle, not harsh, as though the planet is wrapped in a soft glow. Scientists find comfort in how these planets remind us that even in the vastness of space, simple interactions between light and matter can create quiet beauty. Some exoplanets orbit stars so faint that their days are as dim as late evening on Earth. These red dwarf systems create worlds where soft, dusk-like light lasts for ages. The sky might appear in muted tones, with long shadows that never fully fade. The slow-burning nature of these stars means their planets could remain stable for trillions of years, offering a peaceful, steady environment. Astronomers think life, if it exists there, might experience calm cycles without strong seasons or rapid changes. This gentle stability recalls thoughts shared by Carl Sagan, who often spoke about the slow unfolding of cosmic time. These dimly lit worlds move through their calm orbits with a kind of patience that feels soothing to imagine. Their quiet skies remind us that not all beauty is bright. Some exoplanets may be covered in thick layers of clouds made of minerals, metals, or glass-like particles. On these worlds, winds might blow tiny fragments of quartz or silicate crystals, creating a shimmering atmosphere that sparkles under starlight. Although the idea sounds dramatic, from a distance it feels strangely peaceful, like watching a soft dusting of snow drift across a landscape. Scientists detect these mineral clouds through subtle signatures in the light passing through a planet's atmosphere during transit. Early theories of atmospheric chemistry, paired with modern space telescopes, help uncover these details. The clouds move slowly in global circulation patterns, shaped by temperature and pressure rather than storms. Imagining these calm, glittering layers gives a sense of quiet wonder, as if the universe creates beauty even in the most unexpected materials. Some exoplanets orbit two stars instead of one, creating gentle rhythms of dual sunrises and sunsets. These circumbinary worlds move through gravitational patterns that once seemed too complex for planets to survive. Yet they do, and they remain remarkably stable. Watching such a sky would feel like living inside a cosmic dance, with warm light shifting softly as the stars move. The idea of two stars orbiting each other dates back centuries. refined by astrophysicists studying how gravity works in multi-star systems. It reminds us of Einstein's profound work on the curvature of space-time, shaping the paths of objects as they move. These planets follow those curved paths with steady grace, never rushing. Their dual-star days and nights unfold with a calm rhythm that would feel soothing to anyone imagining the scene from afar. Some planets are believed to have surfaces made of diamond-like carbon, created under immense pressure deep within their interiors. From afar, such a world might look dark and calm, with a subtle sheen. Scientists infer these possibilities based on the carbon-rich stars they orbit, where planets form from different materials than Earth. These exotic compositions connect to early ideas in chemistry and the study of matter. The thought of a world made mostly of crystallized carbon brings a quiet fascination, not because of its value, but because of its stillness. These planets likely cool slowly, their surfaces solidifying into stable layers that remain unchanged for ages. They drift through space as steady, heavy spheres, shaped by pressure rather than light. Their deep, silent interiors remind us that the universe creates worlds in more forms than we once imagined. Some exoplanets orbit in such stretched paths that their seasons last for centuries. As they move through their elongated orbits, long periods of distant cold slowly transition into warm eras when they approach their star. The changes unfold at a pace so slow that a single lifetime might see only part of one season. Astronomers study these orbits using principles first outlined in Kepler's laws and later understood through Einstein's work on gravity. These long, gentle cycles create a peaceful sense of time. Imagining life on such a world feels like picturing a place where patience is part of nature itself. Nothing rushes, everything unfolds gradually. These slow seasons paint a calming image of worlds where change happens like the drifting of clouds, soft and unhurried. Some planets are locked in resonant orbits, meaning they move in perfect mathematical ratios with neighboring worlds. For example, one planet may orbit twice for every 3 orbits of another. These patterns create gentle gravitational harmonies, stabilizing the planets for billions of years. Astronomers discovered these resonances by studying rhythmic signals in starlight, similar to listening for repeating notes in a quiet song. Such arrangements remind scientists of the mathematical elegance often admired by Einstein and other physicists. These planetary harmonies are not loud or dramatic. They're soft, steady, and balanced, unfolding in the background of the galaxy. Imagining this cosmic rhythm brings a sense of calm, as if the universe itself is gently humming. Some exoplanets may have atmospheres rich in methane, ammonia, or other simple molecules that create soft pastel skies. Depending on the star's light, the sky could appear pale blue, lavender, or even a gentle green. These colors form when sunlight scatters through gases, a process described by early scientists studying optics. The atmospheres on these worlds might be thick and stable, smoothing out temperature changes and creating quiet, mild climates. When astronomers model these skies, they often picture sunsets that last for hours, with colors slowly shifting across the horizon. The imagery feels peaceful, like watching watercolor clouds drift in slow motion. These soft skies remind us how even simple gases can create beauty when touched by starlight. Some planets orbit so far from their stars that their surfaces remain frozen and dim, yet they still move through their orbits with steady reliability. These distant worlds receive only a faint glow, similar to starlight seen during a winter evening. Despite the cold, they remain stable for billions of years, quietly circling in the deep outskirts of their systems. Astronomers detect them through long-term observations, measuring slow changes in the star's motion. The patience required echoes the thoughtful approach of early scientists who believed in careful, steady measurement. Imagining these distant planets feels like picturing silent landscapes under soft, pale light. They remind us that even in the coldest parts of the galaxy, calm and enduring worlds continue their journey without ever hurrying. In the gentle quiet of space, some exoplanets may have weather unlike anything on Earth. Instead of rain made of water, their skies could release showers of molten iron or droplets of liquid glass that fall slowly through dense clouds. While this sounds intense, imagining it from far away brings a strange calmness. The droplets drift steadily, guided by gravity, moving in patterns that stay the same for millions of years. Scientists study these weather systems by analysing the faint signatures in starlight as it passes through a planet's atmosphere. These clues help them understand temperatures, wind speeds, and chemical compositions. It's the same careful, patient method astronomers have used for centuries. When you picture these slow, shimmering storms moving across a quiet alien horizon, the universe feels like a place filled not just with extremes, but with gentle rhythms hidden inside even the most unusual worlds. Some exoplanets are thought to have magnetic fields far stronger than Earth's, creating vast, shimmering auroras that stretch across their skies. These glowing curtains of light, driven by charged particles, may be visible from space as soft waves of colour. Scientists detect hints of these magnetic fields by studying radio emissions or changes in atmospheric chemistry. The idea connects to early discoveries in electromagnetism and the later work of physicists who explored how charged particles move. Imagining these auroras brings a sense of peace. Instead of Earth's brief displays, these lights might glow for days or weeks, rippling slowly like calm ocean waves. They would illuminate the landscape in quiet blues, greens, or purples. Thinking of such endless, gentle lights drifting across an alien sky creates a soothing picture of a world where nature expresses itself in soft, luminous patterns. Some exoplanets may carry thick atmospheres filled with hydrogen, creating a gentle cushion of gas that blankets the entire world. These atmospheres can stretch high above the surface, producing a soft, hazy glow when starlight filters through them. Astronomers detect hydrogen by observing how it absorbs specific wavelengths of light during a planet's transit. This method is one of the simplest and oldest in atmospheric science, yet it remains powerful. The thought of a planet wrapped in such a light, airy envelope feels calming, as if the world is protected by a vast, invisible pillow. These atmospheres can smooth out temperature changes and keep the planet in quiet equilibrium. Imagining the soft, muted horizon of such a world brings a sense of serenity, reminding us that even the simplest elements can create landscapes filled with stillness. Some planets orbit stars that pulse gently, expanding and contracting over time. These stars, called variable stars, create changing patterns of light that wash over their planets in slow, rhythmic cycles. The brightness may rise and fall over days, months, or even years. This gradual shift creates seasons of light rather than temperature. Astronomers study variable stars using methods dating back to early astrophotography, refined by modern space telescopes. Einstein's work on relativity helped explain how these changes relate to mass and energy. Imagining a world illuminated by a star that slowly breathes creates a peaceful feeling. Days would gently brighten and dim, like the soft flicker of a candle. These planets move through their orbits surrounded by a quiet, ever-changing glow, offering a view of time that flows like a calm pulse. Some exoplanets sit inside thick nebulae or dusty regions of their galaxies, meaning their skies might always appear hazy and muted. Instead of a clear view of the stars, their atmospheres would filter light into soft, diffused colours. Scientists detect these dust-rich environments by observing how starlight is reddened as it travels through the material. The idea connects to early studies on interstellar dust and light scattering. Imagining life on such a world feels like picturing perpetual autumn haze, warm, gentle, and subdued. The sunlight would arrive softened, creating long stretches of calm daylight without harsh shadows. These planets orbit quietly in regions where new stars often form, making them part of a peaceful cosmic nursery. Thinking of these hazy skies brings a sense of tranquility, as if the entire world lives beneath a soft, glowing veil. Some exoplanets may lie close to massive gas giants, locked in gentle, gravitational interactions that keep their orbits steady. These worlds, sometimes called exomoons or potential moons-to-be, move in synchronized patterns shaped by the giant planet's pull. The gravitational balance is delicate but stable, like two dancers moving slowly together. Astronomers search for these small worlds by studying slight wobbles or timing changes in the giant planet's transit. The technique echoes early measurements of Jupiter's moons and the steady, methodical work of past astronomers. Imagining a small world orbiting a giant one brings a feeling of protection and calm. The night sky would be dominated by the soft glow of the massive planet, filling the horizon like a silent guardian. It creates a scene of gentle companionship in the dark of space. Some planets may be so young that they are still glowing with leftover heat from their formation. These warm newborn worlds radiate softly in infrared light, like embers from a fire slowly cooling. Astronomers detect them using sensitive instruments that observe heat rather than visible light. Their glow connects to early studies on thermal radiation and the physics of heat transfer. These young planets are still shaping their mountains, valleys, and atmospheres, but the changes happen slowly, over millions of years. Imagining these glowing worlds brings a quiet sense of beginnings. They sit in the darkness like warm stones, cooling gradually as they settle into their long orbits. Their gentle warmth makes them feel alive in a peaceful way, like the slow heartbeat of a forming world. Some exoplanets may contain deep, global oceans hidden beneath thick layers of ice. These subsurface oceans remain warm due to pressure and internal heat, creating vast, dark seas untouched by storms or wind. Scientists study these possibilities by observing how light interacts with the planet's outer layers and comparing them to icy moons in our solar system. The idea traces back to early explorations of Europa and Enceladus. Imagining such an ocean creates a sense of deep calm. The water moves in complete darkness, undisturbed for millions of years. No waves crash, no winds blow, just slow, silent currents drifting through the depths. These worlds remind us that life-giving environments might exist in the quietest, least visible places. Some exoplanets orbit stars with strong ultraviolet radiation, yet their atmospheres may create protective layers that scatter the harmful light. This scattering can produce soft, glowing skies similar to Earth's blue, but with different colors depending on the gases present. Scientists detect atmospheric shielding by analyzing how light filters through the upper layers during transits. The idea builds on early optical science and atmospheric physics, imagining a world where the sky gently glows in lavender, teal, or pale gold brings a peaceful feeling. These protective atmospheres offer stability, shielding the surface from harsh radiation while creating calm, even lighting. Such planets remind us that even in challenging regions of space, nature finds quiet ways to create balance. Some exoplanets lie within star clusters, meaning their night skies could hold thousands of bright stars instead of a few scattered ones. These worlds experience nights filled with soft, twinkling light, creating a sky that feels almost like a cosmic garden. Astronomers study star clusters using careful measurements of stellar motion, a technique that connects to some of the earliest work in astrometry. Imagining such a sky brings a sense of wonder and calm. Instead of darkness, the night would be a gentle glow of countless points of light, each steady and unhurried. These planets move through dense stellar neighborhoods where stars form and evolve together, creating a sense of cosmic community. Thinking of these star-filled nights feels like picturing a peaceful celebration that never ends. Some exoplanets are believed to have surfaces shaped by slow volcanic activity. Instead of violent eruptions, their volcanoes may release gentle flows of molten rock that cool gradually, creating smooth plains and soft, rounded mountains. These calm, volcanic worlds glow subtly in infrared light, which astronomers can detect using sensitive space telescopes. Their internal heat comes from long-lasting radioactive elements, a concept first explored in early geophysics and later refined through studies of planetary formation. Imagining these worlds feels like picturing landscapes formed by time rather than force. Lava spreads quietly, shaping valleys and ridges with patient motion. The atmosphere, if present, could fill with warm, drifting vapors that settle slowly back to the ground. These planets remind us that even processes associated with fire can unfold gently on cosmic timescales, creating worlds that change softly across millions of years. Some exoplanets move in orbits so precisely circular that their distance from their star never changes. This creates an environment with steady temperatures and predictable light, offering a calm stability rarely found in more elliptical orbits. Astronomers identify these near-perfect circles by studying the timing of planetary transits and the subtle tug they exert on their stars. These measurements rely on methods first developed centuries ago, improved by modern physics and precise instruments. Imagining life on such a world feels like picturing a place where every sunrise arrives at the same gentle angle, and every season blends smoothly into the next. There are no sudden shifts, no extremes, just a quiet consistency shaped by gravity's balanced pull. These planets reveal how nature sometimes prefers harmony, crafting orbits that remain unchanged for billions of years. Some exoplanets orbit extremely bright stars, bathing the worlds in a steady glow that softens shadows and creates warm, even lighting. Their skies might appear pale yellow or white, with brightness that feels gentle rather than harsh, because of the filtering effects of their atmospheres. Astronomers study these systems using spectroscopy, a method tracing back to early experiments on light by pioneers like Newton, and later expanded by modern astrophysicists. Despite the intense energy of their stars, these planets maintain stable climates due to thick atmospheres that distribute heat evenly. Imagining such worlds brings a peaceful picture of long, glowing days that never feel too bright, where light flows smoothly across the surface like warm water. These planets show how even powerful stars can create environments that feel calm and gently illuminated. Some exoplanets orbit tiny stars that emit most of their energy in infrared light. On these worlds, the illumination would feel soft and warm, as if the entire landscape were bathed in a gentle ember-like glow. Colours might appear muted or slightly altered, creating a calm, dreamlike atmosphere. Astronomers study these planets through infrared observations, a method grounded in early discoveries about heat radiation, and later expanded through advanced detectors. These worlds often orbit close to their stars, completing their orbits in days or weeks, yet their slow-moving light creates a sense of serenity. Imagining a horizon lit by this gentle radiance feels soothing, like watching a sunset that never quite fades. These planets reveal that even the dimmest stars can produce worlds filled with peaceful warmth. Some exoplanets have surfaces coated in thick layers of organic molecules that formed over billions of years. These materials may create dark, soft terrain that absorbs light and stays cool. Scientists study these possibilities by comparing distant worlds to carbon-rich moons such as Titan. Early experiments in organic chemistry and atmospheric science helped shape these ideas. Imagining such planets creates a picture of quiet landscapes where winds move slowly across dark plains, carving gentle patterns over time. The surface might feel soft underfoot, with faint glimmers appearing only when the sun strikes at the right angle. These worlds remind us that life's building blocks exist everywhere, forming peaceful environments even where life itself may never arise. Some worlds are tidally locked not only to their stars but also to neighbouring planets, creating complex gravitational relationships that keep their rotation steady. On these planets, one side may face another world constantly, offering a permanent view of a companion planet hanging in the sky like a quiet lantern. Astronomers detect these resonant rotations by analysing subtle timing differences in transit data. The idea connects to early studies of the Moon's rotation and modern orbital dynamics. Imagining such a sky feels calming. The companion planet would rise in the same place every night, glowing softly in reflected light. This unchanging view gives the world a sense of cosmic companionship, a reminder that even in space, objects can stay connected in rhythmic harmony. Some exoplanets are believed to have crusts made of heavier elements like magnesium, silicon, or iron, shaped slowly by ancient geological processes. These dense surfaces cool over billions of years, forming stable terrains with little tectonic activity. Scientists infer these compositions by studying the star's elemental makeup, an idea rooted in early astrophysics and later refined through stellar spectroscopy. Imagining such a world feels like picturing a place where silence hangs over vast plains and low mountain ranges. The landscape would be solid and enduring, unchanged by quakes or rapid shifts. These planets remind us that not all worlds are restless. Some settle peacefully into their final forms, holding their shape for ages beyond human understanding. Some planets may have atmospheres rich in carbon dioxide, creating warm, stable climates similar to early Earth. These atmospheres can trap heat gently, maintaining consistent temperatures that change slowly over centuries. Astronomers analyze the absorption patterns in starlight to detect carbon dioxide, using methods shaped by decades of research in atmospheric physics. Imagining such a world brings a sense of calm. The air would feel dense and warm, creating soft winds that move steadily across the surface. Sunsets might stretch for long distances, painting the sky in muted reds and oranges. These planets offer reminders that even simple gases can create environments filled with stability and quiet beauty. Some exoplanets orbit so far from the galactic center that their skies contain fewer stars, offering nights that feel emptier yet deeply peaceful. These regions of the galaxy have lower stellar density, creating wide, dark skies where each star stands alone. Astronomers study galactic structure using mapping techniques developed from early star catalogues and refined with modern surveys. Imagining such a world brings a sense of solitude without loneliness. The night sky would feel open and uncluttered, like standing in a vast, quiet desert. Each star would appear crisp and bright against the dark, creating a calm, minimalist landscape. Overhead, these planets remind us that beauty can be found in silence and simplicity. Some exoplanets orbit stars with gentle solar winds that flow softly through the system. These winds interact with planetary atmospheres to create faint glows or soft waves of charged particles that move quietly through the upper layers. Scientists detect these winds by watching how starlight flickers as it travels through the stellar environment. Einstein's work on energy and radiation helped lay foundations for understanding these flows. Imagining a planet touched by gentle stellar breezes feels soothing, like a world where the sky itself breathes softly. These subtle interactions create peaceful, shifting patterns high above the surface, offering a reminder that even the smallest motions in space can be graceful. Some exoplanets may lie so close to the central bulge of their galaxies that the night sky glows with a soft golden haze. The dense concentration of stars in these regions creates a warm, ambient light that never fully fades, even at midnight. Astronomers study these worlds by observing how the gravitational pull of the bulge influences their orbits, a concept connected to Einstein's work on mass and curved space. Imagining life on such a planet feels like picturing a world wrapped in gentle, permanent twilight. The sky would be filled with countless faint stars shimmering behind a glowing background, making darkness feel more like a peaceful dim glow. These planets remind us that not all nights are black. Some are painted with calm, continuous starlight that softly illuminates the landscape. Some exoplanets are thought to have surfaces covered in frozen gases like nitrogen or methane, forming smooth, icy plains that stretch for thousands of kilometers. These frozen worlds reflect light gently, creating a soft, bluish sheen that astronomers can detect from afar. Scientists study their reflectivity using techniques rooted in early optical physics and refined through space-based telescopes. Imagining such a landscape brings a sense of stillness. The air would be thin and quiet, with only faint breezes moving across frozen dunes. The light would feel cool and calming, like a winter morning that never fully warms. These planets remind us that silence can take many forms, including the peaceful hush of an icy world untouched for billions of years. Some exoplanets orbit stars rich in heavy elements, suggesting that their own surfaces may contain rare minerals or metallic crystals. These materials might form shimmering terrains that glint softly under starlight, producing gentle sparkles across the ground. Astronomers infer these possibilities by analysing the chemical signatures of the stars they orbit, a technique that developed from early spectroscopy. The idea of a metallic landscape may sound intense, but from a distance it feels serene. Light bouncing slowly off smooth surfaces, creating a quiet glimmer. The terrain would be firm and stable, shaped by slow geological processes. These planets remind us that even the most exotic materials can form calm, beautiful landscapes when shaped by time and starlight. Some planets orbit stars that rotate very slowly, creating long, gentle cycles of energy output. These slow rotations produce stable environments for their planets, with light that changes gradually over decades. Scientists study stellar rotation using methods grounded in astrophysics and supported by data from long-term sky surveys. Imagining a world lit by such a patient star brings a sense of deep calm. Days and nights would unfold in smooth transitions without sharp changes in brightness. The planet would experience a soft rhythm of light, almost like breathing. These slowly rotating stars teach us that the cosmos has its own pace, often much slower and gentler than anything we experience on Earth. Some exoplanets move through regions shaped by ancient supernova remnants, where clouds of dust and gas continue to drift quietly for millions of years. These planets orbit their stars while surrounded by faint, colourful nebulae that glow softly in ultraviolet or infrared light. Astronomers detect these environments by studying emission lines from the surrounding material. These glowing clouds connect to the life cycles of stars, an idea explored through decades of astrophysics. Imagining such a world feels like picturing a planet inside a peaceful cosmic painting. The sky might show soft reds, blues or greens, spread out like watercolours across the horizon. These planets remind us that even after powerful events like supernovae, the universe settles back into calm, creating beauty from long quiet remnants. Some exoplanets may orbit stars with extremely stable magnetic fields, creating calm environments free from intense flares or storms. These stable stars offer steady light and predictable conditions, which can help planets maintain quiet climates. Scientists study these magnetic fields using measurements of starlight polarization and radio emissions, techniques that grew from early electromagnetic research. Imagining a world under such a stable star brings a sense of comfort. Days would pass quietly, with no sudden bursts of radiation. The climate would be slow-moving and gentle, shaped by consistent energy from the star. These planets remind us that calmness in space is often linked to harmony in the stars themselves. Some exoplanets may be covered in fine dust that drifts slowly across the surface, carried by gentle winds. These dusty landscapes might resemble quiet deserts, with dunes shaped over millions of years. Astronomers study dust-rich atmospheres by observing how they scatter light, using principles first explored in classical optical experiments. Imagining such a world creates a sense of soft solitude. The ground would feel powdery and light, shifting subtly as breezes pass. The sky might appear muted, filtered through suspended dust that softens sunlight into a warm, diffuse glow. These planets remind us that even barren landscapes can hold a deep, calming beauty. Some planets orbit stars in binary systems where the companion star stays far away, creating rare but gentle bursts of reflected light. Every few hundred years, the second star might brighten the sky slightly as it moves closer in its slow orbit. Astronomers track these dual star dynamics using precise measurements of stellar motion, a technique rooted in early celestial mechanics. Imagining such a world brings a sense of quiet anticipation. Most nights would be dark and steady, but once in an age the sky would glow a little more, like a soft celebration. These planets move through long, peaceful cycles that remind us of the universe's patient, steady rhythms. Some exoplanets may have deep canyons formed by ancient rivers or liquid flows long since frozen or evaporated. These canyons stretch for hundreds of kilometers, carved slowly over ages. Scientists detect them through changes in reflected light and comparisons with surface models from our own solar system. The idea connects to early geological theories about erosion and landscape formation. Imagining such a canyon brings a feeling of vast, quiet space. The walls would rise gently on either side, holding cool shadows that never rush away. These planets remind us that the universe shapes landforms with time rather than haste, creating peaceful places carved by ancient motions. Some exoplanets might orbit stars whose light flickers with soft variability caused by spots on their surface. These small changes produce gentle shifts in brightness that wash over the planets in rhythmic waves. Astronomers study these patterns using long-term photometry, a method rooted in early studies of stellar cycles. Imagining a world lit by this slow, natural flickering feels like picturing a room illuminated by a candle with a slight steady pulse. The changing light would create subtle variations in color and shadow, offering a quiet, soothing visual rhythm. These planets remind us that even imperfections in stars can create gentle beauty across the galaxies. Some exoplanets move through regions of space filled with faint cosmic rays, but their thick atmospheres soften and scatter the energy before it reaches the surface. This natural shielding creates a calm, muted environment where radiation arrives as a gentle whisper rather than a harsh force. Scientists study these interactions using principles first shaped by early particle physics and expanded with modern space observatories. Imagining such a world brings a sense of quiet protection. The sky might glow with a soft haze as particles interact with atmospheric gases, creating delicate, shimmering patterns high above. These planets remind us that even the most energetic elements of space can become gentle when filtered through layers of calm air, turning potential chaos into a serene, steady glow. Some exoplanets orbit stars that rotate so fast they flatten slightly at the poles, causing their light to vary gently across different angles. This phenomenon, known as gravity darkening, produces subtle changes in brightness as the planet moves through its orbit. Astronomers study these variations using high-precision photometry, a method built on centuries of careful observation. Imagining a world illuminated by such softly shifting light feels peaceful. Each phase of the orbit brings a slightly different hue or intensity, like living under a sky that changes mood slowly and gracefully. These planets show how even the shape of a star can create gentle rhythms that echo across its system. Some exoplanets travel in groups through their orbits, forming multi-planet families arranged in delicate gravitational patterns. These systems remain stable because each planet's motion gently influences the others, creating a cosmic choreography that lasts for billions of years. Astronomers study these patterns using orbital mechanics, an area deeply connected to Kepler's and Newton's work. Imagining a world in such a system feels soothing, like watching a slow, graceful dance where every step is predictable. The planets move in harmony, never colliding, never rushing. Their interactions create a peaceful balance that reflects the quiet order hidden within the universe. Some planets may have thick layers of fog covering their surfaces. This fog could be made of water, methane, or even exotic chemicals depending on atmospheric composition. It absorbs light softly, creating calm landscapes where everything appears muted and hazy. Scientists detect hints of such fog by observing how starlight dims or scatters as the planet passes in front of its star. Early atmospheric studies laid the groundwork for these methods. Imagining such a world feels like walking through endless morning mist. The sun would rise slowly, its rays filtered into gentle beams. These fog-covered planets remind us that nature often creates beauty, not in sharp detail, but in soft, veiled light. Some exoplanets orbit stars that are part of loose-moving groups, clusters of stars drifting together through space. These stellar families travel quietly across the galaxy, maintaining gentle companionship for hundreds of millions of years. Astronomers identify moving groups through shared motion and velocity, concepts connected to early celestial navigation. Imagining a world in such a group feels peaceful. The night sky would hold familiar star patterns that barely shift over generations, offering a sense of continuity. These planets remind us that even stars can form friendships that last across cosmic time. Some planets may be surrounded by faint halos of dust, created by ancient collisions or slow erosion of moons and rings. This dust scatters starlight into soft glows, creating a gentle crown around the planet. Scientists detect these halos by studying how light brightens or dims at specific angles. Early theories of light scattering helped shape these techniques. Imagining a world with such a halo feels calming. The glow would rise like a quiet aura above the horizon, illuminating the sky with a subtle radiance. These planets show how even the remnants of old events can form peaceful beauty. Some exoplanets orbit very young stars still surrounded by swirling disks of gas and dust. These systems are in the earlier stages of formation, but the movement is slow and steady. Astronomers study these environments through infrared and radio observations, connecting back to early models of solar system formation. Imagining these planets brings a sense of beginnings. The sky might show faint ribbons of dust arching across the stars, glowing softly as they catch the light. These planets remind us that creation itself can be gentle, shaped not by sudden change but by patient, quiet motion. Some exoplanets may have slow, drifting jet streams high in their atmospheres, moving not rapidly like Earth's, but gently, almost lazily. These atmospheric flows distribute heat evenly and create stable climate zones that shift only gradually. Scientists detect them by observing tiny variations in temperature across the planet's surface. The study of atmospheric dynamics traces back to early fluid physics. Imagining such a world feels soothing. High winds that move like soft waves rather than storms, shaping clouds into long, graceful streaks. These planets show how motion can be peaceful instead of chaotic. Some planets experience eclipses not just from moons, but from other planets in the system. These planetary eclipses occur rarely, but when they do, they dim the world in a gentle shadow that moves slowly across the surface. Astronomers detect such events by studying subtle light curves in multi-planet systems. The idea connects to early eclipse observations on Earth. Imagining such a moment feels serene. The sky darkens slightly, the temperature cools gently, and the landscape settles into quiet anticipation. These planets remind us that shadows can be soft and calming. Some exoplanets orbit stars surrounded by ancient, faint planetary rings that formed before the planets themselves. These rings drift slowly, shaped by the star's gravity rather than a planet's pull. astronomers study these delicate structures through careful analysis of starlight. The idea traces back to early studies of Saturn's rings and gravitational models. Imagining such a world brings a sense of wonder. The sky would hold subtle arcs of light that shift with each orbit, glowing softly like brushstrokes across the heavens. These planets show that even the earliest materials in a system can continue to create gentle beauty long after their origins. Some exoplanets drift through regions where interstellar dust is incredibly fine, almost like cosmic powder. This dust softens the starlight before it reaches the planet, creating skies that glow in gentle, muted tones. Astronomers detect these environments by studying how starlight reddens as it passes through the dust, a method developed from early optical research. Imagining such a world feels peaceful. The light would fall softly across the landscape, casting faint, diffused shadows that move quietly with the planet's rotation. The horizon might appear blurred, as if wrapped in a calm veil. These planets remind us that even the emptiness of space contains delicate materials that shape beauty in subtle, comforting ways. Some exoplanets orbit stars with very slow nuclear fusion processes, making the stars dim but incredibly long-lived. These stars shine steadily for trillions of years, offering their planets quiet, continuous warmth. Astronomers study these faint stars through infrared observations and stellar models influenced by modern nuclear physics. Imagining a world warmed by such a patient star brings a feeling of timelessness. Days would be softly lit with no sudden bursts or intense heat. The planet would experience a gentle constancy that might last longer than the age of our entire galaxy. These worlds remind us that longevity itself can create peace, offering a slow and balanced environment. Some planets may be wrapped in global hurricanes that move at extraordinarily slow speeds, taking months or even years to complete a single rotation. Unlike Earth storms, these vast systems drift calmly, shaped by thick atmospheres and stable temperatures. Astronomers infer such atmospheric dynamics by studying thermal maps produced during planetary transits. The science draws from early fluid mechanics and modern climate modelling. Imagining such a storm evokes a strange sense of tranquility. Clouds would spiral gracefully across the sky, barely changing from day to night. The world would feel like it is breathing slowly, wrapped in a soft, gentle motion that never rushes. These planets show how even storms can be quiet when shaped by the right conditions. Some exoplanets are so cold that their atmospheres collapse into frosty layers on the surface during long winters. When the planet drifts closer to its star, the ice gently vaporizes, rebuilding the atmosphere over decades. This slow cycle creates a rhythm of freezing and thawing that feels patient and natural. Scientists study these cycles using thermal observations and models of atmospheric chemistry. Imagining such a world feels like picturing a planet that sleeps and wakes slowly. Winters would be calm and still, with no wind or noise, and the return of sunlight would bring a soft, gradual renewal. These planets remind us that even the harshest climates can move with gentle predictability. Some exoplanets sit near the edges of stellar systems, where gravitational forces from nearby stars tug on them lightly. These soft gravitational interactions cause the planets to wobble gently, producing rhythmic motions detectable in starlight. Astronomers identify these wobbles using techniques rooted in Doppler spectroscopy, inspired by early work on wave behavior. Imagining a world that moves with such subtle oscillations creates a soothing image. The planet's path shifts slightly over long periods, like drifting on calm water. These gentle motions highlight the quiet influence of distant stars, shaping orbits in ways that feel balanced and serene. Some exoplanets may have atmospheres filled with noble gases like neon or argon, creating clear skies with a soft glow. These gases do not react easily, so the atmosphere remains stable for incredibly long times. Scientists detect noble gases through specific absorption lines during transits, building on atomic physics. Imagining such an atmosphere brings a sense of clarity. The sky would appear crisp and clean, with light scattering evenly in all directions. Sunsets might appear simple but beautiful, with soft gradients of colour. These planets remind us that simplicity can be peaceful, offering worlds where the air itself feels quiet and steady. Some planets orbit old, slowly cooling stars known as white dwarfs. These stars shine gently with steady, pale light that remains constant for billions of years. Astronomers detect planets around white dwarfs by observing tiny dips in the star's brightness. Imagining life on such a world feels calming. Days would be bathed in soft white illumination, neither too bright nor too dim. The star would appear small in the sky, its light steady and peaceful. These planets show that even the remnants of stars can provide environments filled with quiet stability. Some exoplanets move through regions of space, influenced by gentle tidal forces from massive nearby objects. These forces stretch and relax the planet subtly, generating internal warmth without causing destruction. Scientists use tidal heating models to study these phenomena, building on early work from celestial mechanics. Imagining such a world feels like picturing a planet warmed from within by a soft natural rhythm. The surface might contain warm valleys or calm geothermal vents releasing slow, steady heat. These planets remind us that even the pull of gravity can become a gentle, life-supporting force. Some planets are surrounded by thin exospheres that extend far into space, made of single atoms drifting quietly above the surface. These exospheres scatter starlight faintly, producing a subtle glow detectable by sensitive instruments. Astronomers study them through ultraviolet spectroscopy, a method that grew from early experiments on atmospheric escape. Imagining such a world brings a sense of ethereal calm. The sky would glow faintly along the horizon, like a soft halo surrounding the planet. These worlds show how even the thinnest layers of gas can create peaceful scenes. Some exoplanets lie so far from their stars that they orbit through deep interstellar cold, yet their cores remain warm due to slow, radioactive decay. This internal heat rises gently through the crust, creating a quiet balance between freezing temperatures and subtle warmth. Beneath the surface, scientists study these thermal profiles using models inspired by geology and astrophysics. Imagining such a world evokes a feeling of quiet endurance. The surface may be cold and dark, but the world remains alive inside, carrying a soft glow of heat that persists through vast spans of time. These planets remind us that warmth can exist even in the loneliest reaches of space. Some exoplanets orbit stars that emit most of their energy as gentle flares rather than steady light. Unlike violent bursts, these soft flares release energy in slow waves that illuminate the planets with a warm, gradual glow. Astronomers study these stars using time-lapse photometry, a technique rooted in early observations of variable starlight. Imagining a world bathed in these slow pulses feels peaceful. The sky would brighten and dim like a calm heartbeat, creating a natural rhythm that repeats endlessly. Shadows would soften and shift in slow cycles, offering a sense of quiet continuity. These planets remind us that even change can be gentle when shaped by stellar rhythms that unfold patiently across cosmic time. Some exoplanets may have deep crusts that trap heat from long-vanished formation events. This stored energy seeps out slowly through warm plains and gentle vents, creating stable climates independent of their distance from the star. Scientists study this internal heat through infrared emissions and geothermal modeling. Imagining such a world feels soothing. The surface would glow faintly in certain regions, providing warmth even during the coldest starless nights. Valleys and hills might hold calm pools of thermal mist rising softly from the ground. These planets remind us that the heart of a world can remain warm long after its birth, offering quiet comfort in the vast cold of space. Some planets orbit stars that drift through quiet, isolated regions of the galaxy where interstellar noise is low. These calm neighborhoods reduce the influence of radiation and cosmic turbulence, creating peaceful environments for planetary evolution. Astronomers study these zones using galactic mapping techniques that trace patterns of gas, dust, and stellar motion. Imagining such a world brings a sense of cosmic silence. Nights would feel deeper and clearer, with starlight appearing crisp and steady. The world would move through a space that feels untouched, tranquil, and unhurried. These planets remind us that the galaxy has places of profound stillness, where stars and planets drift quiet through gentle emptiness. Some exoplanets may have thick layers of photochemical haze, produced when their atmospheres interact with their star's light. These hazes filter sunlight into soft colours, creating skies of muted peach, lavender, or pale gold. Scientists detect them by observing how certain wavelengths vanish or weaken during transits. Imagining such a world feels like picturing a place where the sky always looks like early morning or late afternoon. Light spreads gently through the haze, creating long, diffused shadows. The entire landscape appears calm and softened. These planets remind us that even complex chemical reactions can produce beauty that feels soothing and serene. Some exoplanets orbit in systems with very weak gravitational disturbances from nearby bodies. This stability allows them to maintain perfectly balanced orbits for billions of years. Astronomers detect these quiet systems through long-term measurements of orbital motion, a method rooted in classical mechanics. Imagining such a world feels peaceful. The seasons would never shift abruptly, and the length of each day would remain constant across ages. Everything about the planet's motion would feel steady and predictable. These planets show how harmony emerges naturally in the universe when forces align in subtle, balanced ways. Some planets sit in gentle tidal equilibrium with their stars. Their oceans, if present, would rise and fall in slow, vast motions that unfold over weeks rather than hours. Scientists model these tidal patterns using principles from fluid dynamics and gravitational physics. Imagining such oceans brings a soothing image. Waves would move slowly, creating long, smooth swells rather than sharp crests. The water would reflect starlight in calm ribbons stretching across the surface. These planets remind us that tides, often energetic on Earth, can become elegant and tranquil when governed by distant stars and slower rhythms. Some exoplanets may host floating continents made of light, buoyant rock that drifts on deep oceans. These continents move slowly, guided by mantle currents far gentler than Earth's plate tectonics. Astronomers infer such possibilities by comparing planetary densities and thermal models. Imagining a world of drifting land creates a peaceful scene. Small islands would glide over the surface like quiet ships, moving so gradually that generations might never notice. The oceans beneath would remain calm, supporting these silent travelers. These planets remind us that even land can move gently when shaped by deep, steady forces. Some planets orbit luminous giant stars whose light arrives in rich, warm tones. These stars shine more intensely than the sun but spread their energy across vast surfaces, creating light that feels golden and soft rather than harsh. Scientists study these stars through stellar spectroscopy and luminosity models. Imagining a world under such illumination feels comforting. The sky might glow with warm, honey-coloured hues, casting long, smooth shadows. The landscape would be bathed in radiant calmness throughout the day. These planets show how even powerful stars can produce gentle, soothing environments when their energy arrives in balanced waves. Some exoplanets sit in orbits where meteoroid activity is extremely low, meaning their skies remain clear and untouched for long stretches of time. Scientists detect these safe zones through debris mapping and gravitational simulations. Imagining such a world evokes peace. Nights would be quiet with no streaks of falling debris, only calm, unbroken starlight. The surface would stay pristine, shaped mostly by time and gentle winds. These planets remind us that safety and quiet exist even in space, offering worlds where nothing rushes or disturbs the silence. Some planets move through soft interstellar clouds, filled with ionized particles that glow faintly when illuminated by starlight. This ambient light bathes the world in a tranquil, diffuse radiance. Astronomers detect these clouds using spectral emission lines and radio signals. Imagining such a world brings a dreamy feeling. The sky might shimmer with a perpetual gentle glow, neither bright nor dark. The horizon would blend smoothly with the atmosphere, making the world feel enclosed in a cosmic blanket. These planets remind us that space itself can glow softly, offering peaceful light in even the quietest corners of the galaxy. Some exoplanets may drift within regions where the interstellar magnetic fields are unusually smooth and uniform. These gentle fields shield planets from harsh cosmic radiation, creating environments where energetic particles flow in soft, continuous streams. Astronomers study these magnetic structures through radio wave mapping and polarization measurements, methods that trace back to early electromagnetic research. Imagining such a world feels peaceful. The sky might shimmer faintly as charged particles glide along magnetic lines, creating a silent ballet high above. The atmosphere would remain calm, shaped by steady, predictable forces rather than violent bursts. These planets remind us that even invisible structures in space can create quiet havens, shaping worlds where the balance of forces feels gentle and stable. Some exoplanets orbit stars that spin so slowly their magnetic activity is minimal, reducing the presence of flares or sudden burst of energy. These quiet stars create safe, steady environments where light arrives in a constant calming glow. Astronomers observe stellar rotation using Doppler measurements and long-term brightness tracking. Imagining a world under such a star brings a sense of deep calm. Days would unfold smoothly without sudden brightness changes, and the sky would hold a soft steadiness. These planets show how tranquility can arise when a star's internal processes move at a slow, measured pace. Some planets may host thick, floating layers of atmospheric crystals that drift high above the surface. These crystals could be made of water ice, methane, or even exotic compounds unknown on Earth. As starlight passes through them, it would refract into gentle halos and soft arcs. Scientists study these clouds through spectral scattering models, rooted in early physics and atmospheric research. Imagining such a world feels serene. The sky might glow with pastel rings and faint glimmers, creating a dreamlike vista. These planets remind us that beauty in the universe can come from the smallest particles drifting in silent harmony. Some exoplanets lie within star systems where the central star slowly oscillates in brightness due to internal heat cycles. These slow, rhythmic changes cast gentle waves of light across the planets, creating a natural pattern that repeats over centuries. Astronomers detect these oscillations through precise stellar seismology, which studies vibrations within stars. Imagining a world lit by such cycles feels calming. The landscape would gently shift in tone over long periods, like a cosmic dimmer switch moving with infinite patience. These planets remind us that time in the universe often flows in soft, sweeping motions. Some planets orbit within dusty belts similar to our Kuiper belt, but much thicker and more luminous. These belts scatter light into a soft glow that wraps around the planet like a halo. Astronomers study these structures through infrared imaging and debris disk modeling. Imagining such a world evokes a gentle sense of wonder. Nights would be illuminated by a faint milky radiance, as if the sky were dusted with a quiet silver light. These planets show that even debris, when spread across vast distances, can can become a source of peaceful illumination. Some exoplanets may have deep layers of atmosphere where wind speeds are incredibly low, creating zones of permanent stillness. These calm regions exist where temperature and pressure balance perfectly. Scientists detect these atmospheric layers using Doppler spectroscopy and temperature mapping. Imagining such a world feels tranquil. Clouds would barely move, suspended like soft white brushstrokes across the sky. Sunlight would filter through them gently, changing only with the planet's slow rotation. These planets remind us that true stillness can exist even on worlds far more massive than Earth. Some planets orbit stars with dusty outer layers that filter their light into warm golden tones. These stellar veils create gentle illumination that softens the environment. Astronomers study these dust layers through absorption spectra and thermal emission measurements. Imagining such a world feels comforting. The star in the sky would appear hazy but bright, casting smooth shadows and warm hues across the surface. Every sunset would blend softly into night, with no abrupt shifts. These planets remind us that even imperfections around stars can create peaceful, inviting light. Some exoplanets have rotational periods so slow that a single day may last months or even years. As the world turns, light changes gradually, creating long mornings, endless afternoons, and sunsets that drift across the horizon for weeks. Scientists deduce these rotation rates by analyzing patterns in brightness and thermal emissions. Imagining such a world brings a deep sense of calm. Time would stretch gently, and the sky would shift in slow, graceful gradients. These planets show how the passage of time can feel soothing when nature moves at a leisurely pace. Some planets orbit ancient stars that formed when the universe was young and quiet. These stars shine with a soft, aged glow, their energy diffused by countless millennia. Astronomers determine their age using stellar composition and evolutionary models. Imagining a world warmed by such an old star feels tranquil. The light would be gentle, lacking the intensity of younger suns. The landscape would appear bathed in a warm, timeless radiance. These planets remind us that age can bring peace, even to celestial bodies. Some exoplanets drift through regions where dark matter density is slightly higher, a presence detectable only by its gravitational effects. Though invisible, this gentle gravitational influence shapes their orbits softly over long timescales. Scientists study these effects using galactic models built on Einstein's theories. Imagining such a world feels mysterious, yet calm. The planet moves through space, guided by forces it can never see, following a smooth and steady path. These planets show that even unseen matter contributes to the quiet order of the universe. Some exoplanets may lie in regions where cosmic dust grains are so large that they scatter light into soft, deep colors, rather than the bright hues we know on Earth. This creates skies tinted in gentle browns, muted blues, or even warm greys, depending on the mineral content of the dust. Astronomers study these environments by analyzing scattering patterns in starlight, a method built on early optical experiments and refined through modern telescopes. Imagining such a world feels peaceful. The daylight would be thick and velvety, creating shadows with smooth edges and horizons that blend almost seamlessly into the sky. These planets remind us that even the color of light can be calming when shaped by nature's quiet particles drifting through space. Some exoplanets orbit at extreme angles around their stars, tilting so far that their poles receive more sunlight than their equators. This unusual geometry creates slow, sweeping seasons that move gently across the planet. Scientists identify these tilts through careful modeling of light curves and gravitational interactions. Imagining such a world brings a calming sense of motion. The sun would trace long arcs across the sky at strange angles, but it would do so in a steady, predictable rhythm. These planets show that even unusual arrangements can produce quiet harmony, shaped by the gentle mathematics of celestial motion. Some planets have surfaces coated in tiny reflective crystals created by chemical reactions in their atmosphere. These crystals drift downward like slow shimmering snow, forming a sparkling layer on the ground. Astronomers detect such materials through infrared analysis and comparisons with known mineral signatures. Imagining this world feels serene. The surface would glisten softly under starlight, creating landscapes that glitter not with harsh brightness, but with calm, steady reflections. Each breeze would shift the crystals slightly, producing peaceful, shimmering waves of light. These planets remind us that even chemistry can create quiet beauty. Some exoplanets orbit stars that emit soft, pulsing radio waves. These gentle patterns flow through space like slow music, interacting with the planet's magnetic fields to produce faint, glowing arcs in the sky. Scientists detect these interactions with radio telescopes, building on techniques developed across decades of astrophysical research. Imagining such a world feels soothing. The sky at night might hold delicate streaks of light that pulse faintly, following the rhythm of the star. These planets show how soundless waves can create peaceful displays, turning the cosmos into a quiet symphony of motion and light. Some exoplanets may rotate in such a way that one hemisphere experiences constant twilight, neither full day nor full night. This zone occurs in planets that spin slowly while orbiting stars of moderate brightness. Astronomers infer these conditions through thermal mapping and rotational modelling. Imagining such a world brings a feeling of gentle balance. The sky would hold a permanent soft glow, with colours shifting subtly but never fully changing. These planets remind us that peace often exists in the in-between spaces, where light and darkness meet quietly and comfortably. Some planets move through star systems filled with gentle, swirling gas streams shaped by ancient stellar winds. These currents bend around the planet, creating calm, ribbon-like flows that leave soft marks in the atmosphere. Scientists study these patterns using spectroscopic mapping and simulations of wind interactions. Imagining such a world feels tranquil. The sky might contain faint, wavy structures that drift slowly, illuminated by the starlight filtering through them. These planets show that motion does not always mean chaos. Sometimes it's as soft as strands of silk moving through space. Some exoplanets have surfaces of soft, porous rock that absorb sound completely, creating landscapes where footsteps, wind, and movement produce almost no noise. Astronomers infer such surfaces by studying planetary density and reflectivity, comparing them to quiet, low-density materials on Earth. Imagining such a world brings a sense of deep silence. The air might move gently, but the ground would swallow every sound, creating an environment of complete calm. These planets remind us that silence itself can be a natural feature shaped by geology rather than emptiness. Some exoplanets orbit in systems where the star's light passes through thin layers of circumstellar dust, creating permanent soft shadows across the world. These shadows shift only slightly as the star moves, creating stable patterns of dimness and light. Scientists study these dust layers using infrared imaging and models of stellar outflows. Imagining such a world feels peaceful. The surface would experience muted brightness, as though the star glowed through a delicate curtain. These planets remind us that even filtered light can be beautiful when nature sets the stage. Some planets lie in orbits where their star's gravity gently compresses the atmosphere into layered bands of colour, each shifting slowly as temperatures change. Astronomers detect these bands through atmospheric spectroscopy and thermal analysis. Imagining such a world evokes a soft, sweeping sense of depth. The sky might hold gentle stripes of pale blue, soft pink or silver grey, each blending seamlessly into the next. These planets show how atmospheric pressure can create scenes that feel painted with calm, continuous strokes. Some exoplanets reside in ancient, quiet star clusters where stellar motions slow over time. These clusters drift through the galaxy with a steady, unified movement that lasts billions of years. Scientists study them using astrometry and deep space imaging. Imagining such a world feels soothing. The night sky would hold thousands of stars that barely shift over centuries, offering constellations that remain unchanged across generations. These planets remind us that stability can be found in the oldest neighborhoods of the universe, where everything moves together in gentle, unified harmony. Some exoplanets may orbit through regions where faint streams of interstellar plasma move slowly like drifting fog. These streams interact lightly with the planet's magnetic field, creating soft, shimmering glows high in the atmosphere. Astronomers study these interactions through radio wave monitoring and plasma mapping, fields influenced by early electromagnetic theory. Imagining such a world feels peaceful. The sky might hold subtle moving curtains of light, far softer than auroras, gliding in calm arcs. These planets remind us that even the subtlest forces in space can create displays that soothe rather than overwhelm. Some planets have orbits that align perfectly with their star's equatorial plane, leading to extremely stable climates. These orbits minimize seasonal shifts and keep temperatures steady over long periods. Scientists detect this orientation by studying transit angles and stellar rotation. Imagining such a world brings a sense of balance. Each day would resemble the last, with gentle sunlight and predictable shadows. These planets show how harmony emerges when orbital paths and stellar spin flow in quiet agreement. Some exoplanets may have atmospheres dominated by heavy, slow-moving gases that drift with remarkable calmness. These gases resist rapid motion, creating skies where clouds shift only subtly and winds move as soft breezes. Astronomers detect such atmospheric compositions through spectral absorption patterns. Imagining such a world evokes tranquility. Clouds would shift like slow brush strokes, blending across the horizon in gentle layers. These planets remind us that even the air itself can create a mood of stillness and quiet. Some planets orbit bright stars with smooth, stable nuclear reactions that produce consistent light across billions of years. These stars shine without major fluctuations, creating environments where planets receive steady illumination. Scientists study these stars through stellar modeling and luminosity measurements. Imagining a world under such a star feels comforting. The light would be warm and even, rising each day with predictable calm. These planets show that stability at the heart of a star creates peace across an entire system. Some exoplanets may hold vast plateaus formed not by tectonic collisions but by slow, ancient uplift. Over billions of years, internal pressure moves these surfaces gently upward, creating broad, flat landscapes. Astronomers infer such geological activity through mass distribution and thermal models. Imagining such a plateau feels serene. The horizon would stretch endlessly, undisturbed and level, like a quiet stone plain under a soft sky. These planets remind us that landscapes can grow slowly, shaped by time rather than turmoil. Some planets may orbit inside stellar nebulae so faint that their skies glow with barely visible wisps of color. These nebulae scatter a soft mixture of red, blue, and violet light into the atmosphere. Scientists detect these faint glows using deep spectral imaging. Imagining such a world feels dreamlike. The sky might shimmer with pastel hues that shift gently as the planet moves. These planets remind us that even the faintest remnants of stars can create gentle beauty when viewed from just the right place. Some exoplanets are predicted to have extremely slow orbital speeds, taking centuries to complete a single journey around their star. Astronomers track these long orbits through gravitational data and modeling. Imagining such a world creates a sense of timelessness. Seasons would drift slowly, lasting generations. The sky would change in gradual ways, creating an environment where life, if present, would experience time at a different pace. These planets remind us that the universe moves not only quickly, but also with profound slowness. Some planets may have underground layers of gas that escape gently through tiny surface vents, forming soft plumes that drift upward like quiet breaths. Scientists detect these gases through infrared signatures and comparisons with moons like Enceladus. Imagining such a world feels soothing. These calm vapor plumes would rise slowly into the atmosphere, catching light in delicate ribbons. They would move in silence, shaping the landscape with careful, subtle traces. These planets show how geological activity can be peaceful rather than violent. Some exoplanets orbit stars surrounded by faint, ancient comet trails. Over time, these trails spread into thin, glowing arcs that decorate the sky. Astronomers identify such trails through dust mapping and reflectivity analysis. Imagining such a sky feels magical. Streaks of soft light would hang, still in the heavens, shaped by centuries of quiet motion. These planets remind us that even the remnants of comets, objects once fierce in their journey, can settle into peaceful beauty. Some planets drift in regions where the interstellar medium is exceptionally smooth, lacking turbulence or density shifts. This creates a calm cosmic environment where the planet moves without encountering strong external forces. Scientists study these regions with radio and infrared surveys. Imagining such a world brings a sense of cosmic serenity. Space around it would feel gentle and uniform, like floating through a quiet ocean. These planets show that the universe holds places where even the vastness between stars becomes peaceful. Some exoplanets may orbit inside regions where ancient stellar winds have carved smooth, tunnel-like cavities through interstellar dust. These cavities create a gentle flow of particles that drift past the planet in slow, even motion. Astronomers identify these structures through radio wave mapping and dust distribution models. Imagining such a world feels peaceful. The sky might hold faint, elongated streaks of light as dust glides along invisible currents. These planets remind us that even winds from long-extinct stars can leave behind quiet pathways where matter flows softly across cosmic distances. Some planets orbit faint stars whose light is so gentle that their shadows appear nearly transparent. Instead of sharp outlines, objects cast soft, diffused shapes that fade at the edges. Scientists study these illumination patterns by analyzing the star's spectrum and its distribution of wavelengths. Imagining life on such a world feels calming. The environment would lack harsh contrast, with light settling evenly over hills, oceans, and plains. These planets show how gentle light can create landscapes that feel peaceful and dreamlike. Some exoplanets may have surfaces coated in layers of ancient frost that never completely melt. These frost plains remain stable over millions of years, shaped by small changes in temperature and faint light from distant stars. Astronomers infer their presence through reflectivity measurements and temperature modeling. Imagining such a world brings a sense of serene stillness. The ground would sparkle softly, not from ice storms, but from the quiet accumulation of frozen crystals. These planets remind us that even cold places can hold beauty when time moves slowly. Some planets orbit stars within triple or quadruple star systems where the gravitational pull is delicately balanced. These worlds experience soft variations in light as multiple suns move across the sky in slow patterns. Scientists model these systems using advanced orbital dynamics rooted in classical astronomy. Imagining such a world feels mesmerizing. Sunlight would shift gently in color and brightness, creating long phases of warm glow followed by cooler tones. These planets remind us that even complexity can become soothing when nature finds balance. Some exoplanets may be rich in helium, giving them pale golden atmospheres that glow softly when illuminated. Astronomers detect helium through its distinct absorption lines during transit events. Imagining a world with a helium-rich sky feels tranquil. The air would shimmer faintly as sunlight passes through, creating a warm, gentle radiance. These planets show how even simple gases can transform the sky into a place of calm and quiet beauty. Some planets orbit stars so stable they have changed very little over billions of years. These stars burn fuel at slow, consistent rates, maintaining nearly identical brightness throughout their lifetimes. Scientists study them using stellar evolution models influenced by nuclear physics. Imagining a world lit by such a star evokes deep comfort. Days would feel steady and predictable, and the seasons would remain quietly balanced. These planets remind us that cosmic stability can create the most peaceful environments of all. Some exoplanets may lie in regions influenced by the soft gravitational pull of passing star clusters. These gentle tugs accumulate slowly over time, slightly adjusting the planet's orbit without causing disruption. Astronomers detect these influences using long-term galactic simulations. Imagining such a world feels soothing. The planet drifts along a smooth path, guided by distant stars that never approach too closely. These planets show how even far-off objects shape the cosmos with quiet, patient force. Some exoplanets have atmospheres laden with tiny hydrocarbon particles that absorb light and create muted, warm colors across the sky. Scientists study these particles using ultraviolet and infrared spectroscopy. Imagining such a world feels comforting. The sky would take on shades of soft amber or dusty rose, with sunsets blending smoothly into night. These planets remind us that even simple compounds can produce skies filled with gentle, comforting tones. Some planets may contain deep subterranean oceans trapped beneath layers of warm rock. These oceans never see sunlight but remain stable for billions of years due to geothermal heat. Astronomers propose these environments through density measurements and thermal modelling, ideas inspired by research on Europa and other icy moons. Imagining such an ocean evokes calm. Water would move slowly in total darkness, undisturbed by surface storms. These planets show that peaceful worlds can exist even where light never reaches. Some exoplanets orbit through regions where starlight reflects off enormous clouds of faint cosmic dust, creating a permanent dusk-like glow. Astronomers observe these dust-rich regions through wide-field imaging and reflective modelling. Imagining such a world feels serene. The sky would never become fully dark nor completely bright, offering a gentle, constant half-light. These planets remind us that somewhere in the universe, twilight might last forever. As we drift back from these quiet worlds and return to the gentle dark of our own sky, let your mind settle like stardust finding its place. Every distant planet moves through the universe with patience, following rhythms older than memory itself, and tonight you floated alongside them. If your thoughts feel softer now, let them stay that way. Let the quiet of the cosmos linger a little longer. Thank you for travelling with me through this peaceful corner of the galaxy. Until we meet again among the stars, rest deeply, breathe slowly, and let sleep take you wherever you need to go. Good night, dreamer.